Hello everyone, I am Generation 3DX, a digital artist and AI animator. So let's talk about a very challenging subject, which is how to create new motions, your own custom motions, and add those to a image to video or text to video AI model. Okay, so let's say you have seen a particular motion that humans are doing, such as a particular dance or something like that, and you try to actually input that dance into an AI video model such as Wan video, and it doesn't know anything about it. So you say you caption Irish dancing, for instance, you know, where they do their foot taps and all this kind of stuff very quickly, and the AI model just doesn't know. It just doesn't do it at all, because there's nothing in its training data about Irish dancing. So you think, well, I actually want to have my characters, or I want to have I want to animate Irish dancers. So the only way you're going to be able to do that is firstly find out if somebody else has created a training set for that, and use theirs and hope that theirs is good, or you're going to have to write your own. And I'm just going to say straight away, this is not for the faint-hearted. It's actually very difficult, but it is possible, and I have done it. That I'll demonstrate this by the end of this video to give you some hope that it is actually possible. And you saw the initial videos that introduce this video, which is a pole dancing, and we're going to use the pole dancing motion to demonstrate this motion training, because Wan video does not know anything about pole dancing. I tried, I thought, oh, I might get lucky and see if I can get one of my characters to pole dance. No, it has no idea. So and I'll show you that. So you can put a video up here of me with a caption which just says girl figure on a pole doing pole dancing. And she just sits there and limply moves her arm. She has no idea what to do. But now with that, with our training of pole dancing inserted, this is the result. Okay, so it's not perfect. We still have some artifacts there, because it's actually quite a serious challenge, I think, because there's a lot of complexity in pole dancing. You've got lots of different moves, and you've got the collision between the figure and the pole to take account of, and so forth. So it is actually quite a tall order, this, but it's nonetheless, it's actually valid for this demonstration video to actually just demonstrate the concepts, and we're going to go through all the different steps that you're going to need to do, as well as discuss the concepts and try to get some understanding of the concepts involved, because I say it's pretty advanced stuff, this. But anyway, if you're going to stick with me till the end, you know, I think it'll be worth it, because I don't know of really very many people that have actually tried to make a video about this subject, because I say there's a lot to do, there's a lot going on, and I say it's not for the faint-hearted. Anyway, right, let's go. So in this video we're going to do we're going to basically create a LoRA, which is a low rank adapter, and it's an action LoRA or a motion LoRA. And so this LoRA is basically then going to be added on top of Wan video. Okay, so what that basically means is providing additional training information for the Wan video model, so that during inference, or when you're actually prompting to actually create the videos, you can add that in there. It will actually provide that motion for you. So there are a number of different ways you can actually do this training and create a LoRA. In this case, we're going to be doing a local installation and a local training using one's own PC, my own PC. We're going to be training on my RTX 5090 using Musubi Tuner. There are other models out there, there are other systems out there, but Musubi Tuner seems to be the one which is the go-to, as far as I can see, in order to especially do Wan video. Now there might be other ones for Flux or Huanyan video, that kind of stuff. The basic concepts are going to apply to other systems. So even if you're not using Wan, or you're not using a local installation, just stay with me, because the concepts are important. Okay, because the actual steps the individual steps are going to be different, and the details of the implementation, but the general concepts are something that are hard to grasp unless you have, you know, somebody actually taking you through it and demoing it. Okay, now I'm not going to say for a minute that I'm the all-seeing, all-knowing oracle on this subject. You know, I'm still very much a beginner, but then everyone's a beginner on this because this is completely bleeding edge, cutting edge stuff. You know, we're living the now, and we are creating the future with this stuff. So this is it's a completely new subject for everybody. So we're all kind of, you know, being blind and leading the blind on this. Anyway, so we're going to be using Musubi Tuner. You can get Musubi Tuner by going to the GitHub page, downloading it, and then installing it through GitHub. Take your time in reading the documents because there are a lot of gotchas in this, and there's a lot of things you need to know, basically. And if any doubt, you can always go back to the docs, and they try to keep the docs up to date. It's a live project that's in active development. And if you really get stuck, you can go and ask in the forums, and you usually get somebody who will respond, one of the developers. I use AI a lot to assist me with this, with asking the AI things. I find ChatGPT works well, but you could use Grok or Gemini or any other AI to try to help you with this. But always insist with the AI, say, don't guess, look at the docs and tell me, you know, because the AIs have this terrible habit of just guessing and then bullshitting you, essentially. By saying, yeah, this is what you should do, and they've just made it up. So you've always got to be challenging the AI, saying, read the docs, tell me what the docs say, because the docs are quite extensive, and it might be difficult to find a very specific switch that you need in order to do this. Now, in this video, I'm not going to be doing an exhaustive. I'm certainly not going to do an exhaustive installation to demonstrate the installation of Musubi. We're going to be here for hours and hours if I have to basically go through every single thing. So there's going to be certain kind of granularity that I'm adopting here to try to keep this as brief as I can. But I suspect this video is going to go on for over an hour because there is just so much to take in. So right, so you've installed Musubi, okay. And so what I do in order to kind of control everything, because there is a lot going on here, I actually use Visual Studio Code to manage all the different files that are going on this project. For instance, where we have our video files, that are source videos that we're going to be using, captions, various different configuration files, and command repositories where I keep my commands and things like that. Otherwise, if you're trying to do it outside of a kind of a project manager like this, it can be you can get yourself very confused and wondering where everything is. I mean, you can use, you know, like Notepad++ or something like that, but it gets to be really kind of you lose control. So Visual Studio Code is the one I use for that, and you've also got you've got a command prompt there if you want to use it directly within Visual Studio Code. Although I actually have my command prompt separate. Right, there is actually, I think there is a UI for Musubi, but I don't use it. I find it's just better to do it on the command line because you can have full control over your command prompts and your switches and so forth. I find it's just more work to actually have to, say, put in these various different parameters into text boxes and stuff like that. It's whatever you prefer. Some of you might be scared of command lines, in which case go and use the UI. But we're going to be using command line here in this demonstration. Alright, there is also options to do video motion training using online rented GPUs, and certainly if your GPU is just not up to the task, you're going to have to do that anyway, because say the amount of RAM and the amount of power needed to actually do this is really quite high, to be honest with you. I would say anything short of a 4080 RTX 4080, you're going to be struggling, or a 3090 maybe, but 5 series Blackwell NVIDIA GPUs are really good for this. In my case, it's a 5090, which is just going to rip through this, and within less than 24 hours, you can train, you do a full motion training for one video with that. If you've got a less powerful card, it could take several days. so there are online options. I'm not going to cover them here, but I just let you know that they are available, and you should investigate those if you want to go for a rented GPU. When we are talking about motion training, This is, I mean, it is basically what we're talking about. When we're talking about video, okay, so let's just step back. So some of you may have already watched my video where I did a character LoRA training. So, and that was for Pony SDXL. So that's for static images, where you are trying to basically train the AI to reproduce your character faithfully, and that is actually, if you haven't done that already, I recommend you do that first, and then come back and watch this video, because that's a stepping stone into the whole concept of LoRA training, and it's much easier to do that. Video motion training is another order of magnitude of difficulty in order to get everything working. Okay, and it does require more power as well, I think. But the main thing is conceptually, it's getting things to work is much harder for training motion and action than it is for just training visual information, such as a character, their face, or a background. You know, training like your hotel room or a chateau or something like that. You can train those. You can train those and add those to models, or clothing, you know, or a uniform or something like that to bring out a character. So start with that. I would recommend you start with that first, and I'll link the video to that. You can see that top right. Recommend you do that first, and then after a couple of weeks where you've been bashing your head against that, and then you feel you've blooded yourself on that, you can come back here, and then you can learn about how to do motion video training. Okay, so if you already have done some character LoRAs, that's great. You've done some Pony or SDXL or SD LoRAs, then this is definitely the next step. So you're training motion. So you have a particular set in mind. Say we're talking about Irish dancing or talking about pole dancing. You'll see that conceptually you want to keep it relatively constrained and relatively you have a specific bracketed, targeted area of motion that you want to describe. Because what will happen is, if you try to kind of make it too broad, if you try to kind of say I want to create the motion of an entire dance routine, well, for a start, one video only really goes up to about 8-9 seconds anyway. So you've got to first think, what can I capture within 8 or 9 seconds? You're not going to get an entire dance routine, and it's just going to be too ambitious, because AIs only have so much context, and they only have so much weight that they can apply to all various different aspects to train them up on something. So if you're trying to train it on too many things at the same time, what ends up happening is everything just gets diluted, and you lose the strength of individual motions. So you want to try to limit it to simple motions, and then your source videos are going to basically keep showing that same motion, possibly from different angles, but we can talk about that when we get to source videos. But basically you're making a decision. I want to capture a specific thing, a specific action, a specific motion, and limit it. And if you limit yourself to that, you're going to have a much greater chance of success. If you try to make it too broad, you're going to be disappointed, because it's just going to splatter the AI all over the place, and it's not really going to know what to do. Okay, so saying all that, you're going to see that I've been overly ambitious in this little project here of trying to do pole dancing, because pole dancing is really quite complicated. Okay, and it might have been a better idea had I just said, just stick to a very specific motion that we're going to do, such as a spin around a pole or something like that. Probably would have been a better thing. But you know what? It doesn't matter. I've already done it now. I've already trained it, and I've already done all my training, and I'm not going to do it again. So so limit your goal, and then once you've got your goal, then you need to start selecting and curating your source videos. So let's just quickly run through the key steps that you're going to need in order to actually train a video. So firstly, we have to prepare source videos. Secondly, caption those videos so that the trainer knows what it's looking at and can be guided by your text prompts, essentially, your text captioning. The training itself, and running the training, video training, using your GPU, the commands and caching and commands to actually do the training. And lastly, inference testing. When I say inference, it's a technical term to describe using the video model to create new videos. Okay, so you're basically giving it a text prompt and an image if it's image to video, or pure text prompt if it's text to video, just to tell the model, I want you to create a video of a girl pole dancing. Okay, and that's inference. So that's another big subject. So yeah, four main areas that we're going to cover in this video. Okay, so let's start with that first one, which is the preparation of the source videos. So for this demo, I have curated a set of 16 videos of a pole dancer. This is Jessica Marsh. She does pole dancing training videos on YouTube. So thank you, Jessica. I hope you don't mind me using your motions to record your motions for this. Anyway, so here you can see Jessica. She's doing her stuff very skillfully, and each video is 8 seconds. Okay, you can see they're all 8 seconds long, and they are all roughly the same in terms of, you can see a pole is going down the middle. You've got the figure in the center of the action, which is what the trainer's like. They are describing a very specific thing. Now it is quite complicated, and it's probably too complex. Really, she's doing too many complex motions, which is probably going to the trainer's probably just going to explode trying to do all of these things. So it'll try to do some of them. So normally you'd probably go for something a bit simpler, but nonetheless we can do this and see how well it does. But you can see your scope is limited to pole dancing, pole in the middle, one figure doing stuff around a pole. Okay, and they're all 8 seconds long, and the resolution, I've blown up the resolution here on my 4K, but the actual the resolution of each one I've set to 384 by 384 pixels. So quite small because you'll find that memory constraints just prevent you from training anything really beyond 300 by 300 pixels, but we'll cover that when we get to the configuration file. For motion training, you don't really need a particularly big resolution anyway, because I say you're looking at a human figure that is articulating in a certain way, and it's simply going to record the articulation of that human figure as a series of motions. Now, see, when you're doing SDXL training, like character LoRA training, you have a bigger resolution, like 1024, because you want to capture visual detail and an actual, visual fidelity. Okay, so resolution is going to be higher there for this, just simply because of constraints of memory, and because you really don't need it. You're just recording motion. You don't need a higher resolution. Now there is certain visual details it will try to capture, but those are of secondary importance. The primary importance is to record the motion. Okay, so how you set up these videos. Oh, by the way, you can see it's all square. Just go with square. If you try to do anything which is not a square aspect ratio, it's potentially going to be more difficult for you for when you get to inference. And where you actually want to capture that motion, but just go with square. You don't need to overcomplicate it by doing anything other than an aspect ratio of 1:1. Okay, how you go about setting up and capturing these videos is going to be your own choice. I personally use Premiere, Adobe Premiere, to do that, but you can use other video editors. With Premiere, I find I can actually zoom in, crop, and then select my specific 8 seconds that I want from the timeline. And I'm obviously recording this video. I'm not recording this video, I'm editing this video in Premiere, and I've been using Premiere Pro for about 20 years now. So whichever video processing tool or editing tool that you can do to bring these, curate these sets of videos is going to be your own choice. So you arrange your videos within the data directory in Musubi. So at the top level you've got Musubi Tuner, top level directory, and then you have a data directory, and then you just specify within data for the particular project that you work on. Here I've got videos pole dancing, and I just number the videos very, very simply with just an ordinal system, 0, 1 to 1, 6. This is going to help when it comes to when you're doing your captioning, setting up your captions. All right, so that's your source video set. So you have your source videos arranged, ready to go. So the next stage is captioning, and this is the one where you're probably going to be brought to tears or hair pulling and driving yourself crazy, and because it is the most difficult. This is the most difficult and subjective part of the whole process, and it's the same. It's the same with character LoRA training, SDXL training of images as well. There are lots of different opinions and different methods that you can try to do effective captioning, but captioning is very, very important because it's a guide. It's how you guide the trainer to tell it what it is that you want it to train, and what it is that you want it to ignore. Okay, what do I mean by that? Okay, let's start with pole dancing. Okay, and we'll actually have these videos here. I'm keeping it relatively simple for this one, and I'm going to have the captions the same for every video, and we'll talk about that versus having individual captions for each video. Okay, so what the caption I've created for all of these videos is to basically give it a basic scene. It's a very, very simple caption, really. One girl, pole dancing, dancer spins and twists her body around a pole. Because in every one of these videos, that's basically what's happening. Now, there is a school of thought which says that you could just have no captions at all, and that you basically tell the trainer, the video training, to train the model, to say, just look at these videos and just piece together the general motion. Now, I actually don't think that would work, because you have to give it something. You need to give it some kind of grounding. Okay, certainly one girl, well, it can probably figure out that it's looking at a girl anyway, because they're quite smart, these video models, in the same way the image models. They can piece together, they can figure out that they're looking at that thing. So again, that lends the argument that in theory you could actually do it without a caption at all. But anyway, so we say here we've got a girl, we've got a pole, and it's going to understand dancing, but it does not know what this is. It does not know what pole dancing is. So when you present it with motion and images from a sequential set of images, which it looks at in turn, to then try to piece together a motion, it then figures that you're telling it something, and it then will then associate this thing with that thing that it doesn't know about, because it doesn't know about pole dancing, but you're telling it this is pole dancing, so it then will associate that motion with pole dancing. Now, this is a bit more of a visual clue, because you're telling the trainer, look at this is what she is doing. It's a dancer, and it'll know what a dancer is, because I mean that's a fairly basic concept. It says a dancer is spinning and twisting her body around a pole. So it's going to help it. It's going to help it basically figure out that that's what it's looking at. If you took that out, if you took this explanation out, it could probably still do it, but I think it would probably take longer, and it might be a bit less precise or get confused. So again, there is so much discussion on captioning. I mean, even I've done now, I think I've done about 4 or 5 different motion LoRAs with limited success and some great success. You'll see them. I'll link them at the end. I'll link them on the description, so you can go to my models page at Civit AI, and you've got some of my models there you can play with Wan video. Even then, I still kind of scratch my head and think, do I describe it, or do I don't describe it, and what I don't describe it's going to learn versus what I do describe it will learn. Not very helpful, I realise, but you just have to muck your way through this. It's definitely the hardest part of this by far. At the end of it all, and then you've got the whole discussion about whether you use tagging style. This is a tag, versus natural language, because there's opinion that Wan video loves natural language, as in you just simply say with a grammatically full sentence what it is that thing's doing, like this. This is natural language, okay, whereas this is a tag. So I've actually mixed up tags and natural language. So again, massive debate on that. You're going to have to just muck through and try and see which one works best. If in doubt, just simply describe what the video is doing, what the video is showing. Okay, you might want to consider camera, what is the camera is doing. So for instance here on this one, well, in fact on all of them, probably would have been helpful to have said full body, okay, because you want to say it's a full body shot where you're showing the full body of the figure, and you might want to describe the lighting or how far away the camera is, whether it's close up or something like that, and that might be useful if you want to kind of do a bit more of a generalization. I'm referring to not suitable, not an NSFW kind of content, which I can't really talk about here, but you can get the idea that a lot of the interest in this is in NSFW, because that's just what we're all pervs, I guess. So you might have a close-up, or you might have a full body shot of some NSFW action going on. And so it can be helpful to describe that, I think, because it gives the anchor, it gives the trainer an anchor on what it is that it's looking at. Okay. Anyway, I'm not going to belabor this forever, but essentially, you want to set up your captions, either for a common one for all files. Start with that to begin with. Do a common. Try to just maybe keep it simple and do a common caption for all the videos. And then if that doesn't work, then start exploring and getting into more effort required to actually do individualized captions or generally different variations of captions across the different sets of videos. I had the AI write a script which would basically, as it says, generate individual captions from row file. I just says AI go and write me a script which will do this. This just helped me because when you're starting out, you've got all your videos together. It can be very tedious to actually kind of have to create individual caption files, because this is what you have to do. You have to basically have this. You have to have this set up here. Yeah, you have to have an exact match of the name of the video file with the caption file. So that caption must have the same name .txt as that MP4 file. The O1 and the O1 has to match. So what I would do is I would have all my captions together in a single file, and then I'd run a script just to create the individual text files for that. So again, a certain degree of automation and inventiveness and scripting is your friend in this, as I say, because otherwise it can get very, very tedious, and you can lose track of what it is that you're doing. There are other tools. There are various different utilities out there. In fact, you can do standalone applications which will do this for you as well. So you just feel free to kind of explore those options as well. Okay, so I think that's all I'm going to talk about on captioning for now. Okay, so now let's go and talk about the actual training steps. Musubi Tuner command line, or even if it was UI, it's going to render down to command line. Is basically a command, and the docs will basically tell you what the various different switches are for this command in order to do the training. So this is basically the command that we're going to go through. Okay, and there's obviously a lot going on here. I'm not going to cover every single one of these. We're just going to go through the basic, some of the most important ones. Okay, so you would run this command from a command prompt. Now I've noticed I've got two here, just to add even further complexity. And let's actually just, before we get into discussing these in detail, let's actually talk about Wan 2.2. Okay, so if you're doing anything else for any other model, which is just a single unified model, then this doesn't apply, so you can skip this section. Okay, but for those who are training LoRA for Wan 2.2, there are important concepts to consider. So any of you who are familiar with Wan 2.2 will know that this is a mixture of experts video model, and what we mean by mixture of experts, we mean that you have an expert which is for gross level, gross broad motion training at high noise levels, and then fine low noise level for fine finessing and details. Okay, so this explains the high, and I talk about this in my video last time, my last video about Wan 2.2. Mixture of experts video, and there are other mixture of experts AI models out there, not necessarily related to videos, but for general other concepts related to AI stuff. So a mixture of experts, or MOE as it's called, high and low noise. For the high noise, we have to do 2 training prompts. Okay. So we're doing 2 separate training prompts for the high noise model and the low noise model. So the high noise model will have different parameters to the low noise. Generally speaking, it's going to be you need to do fewer epochs, train it over a shorter period of time, whereas the low noise model needs a longer period, and then there are these max time steps. So very important that you get these 2 right. So this one, you just set the high noise to 900, 1000. Low noise is 1 to 400, because they're different. They're different steps. They're different parts of the process of noise, basically removing noise from an image in order to basically then recreate the image from a text prompt. Anyway, very, very, very abstract stuff. But just know that there are differences. There are differences between the high and the low noise aspects of WAN. Okay, and the fact that you have to train 2 separate LoRAs. Okay, and then you're going to insert these 2 separate LoRAs at the end. So on our inference here, we can see that we've got our high noise LoRA here, and we've got our low noise LoRA here within our workflow. All right, so back to the command, and so that ends the tangent on the discussion of Wan 2.2. So going back to general discussion now about training steps, there are 2 pre-steps that you have to do first, and this is the caching of the text encoder and the caching of the latents. So these have their own. You run these commands before you start your training. So that what that does, it's a massive performance and memory save, essentially, in that. So it doesn't have to keep reloading and rereading the text encoder and rereading the VAE, variational autoencoder, which is the way it basically separates out images into AI weights and all this kind of stuff. Very, very technical. But you just run these 2 commands first. They're very specific commands to be run. And your T5, your text encoder, for instance, will be a very specific text encoder to use with WAN. Just follow the documents on which ones to use there, because if it's not the correct one, you'll get errors. You're going to get lots and lots of errors as you're learning how to do this. And I say, allow yourself several weekends, at least several, I'd say 3 or 4 weekends, to really get yourself in on the ground floor on this, because I say it's not easy, and it requires a lot of persistence. So yeah, when you're going into this whole project, be prepared to slog it out. Okay, it's not something you're just going to pick up and handle and do within a few hours. It's multiple days of work to get to even the ground floor. Okay, right. So anyway, cache your text encoder and cache your latents. Okay, now in all of these commands, we should talk about the TOML file, or the config file. So you can see here we've got our reference to our TOML file. So let's have a look at the TOML file before we really get into the actual commands themselves. Okay, so here's our TOML file. So you can see here's our video directory. We've got datasets. It's just this is one section here, datasets. We've got our video directory. And you see here, this is where we had our videos. So we've got videos pole dancing. We've got a caching directory, which you set, and that's fine. You can just use that for just keep that the same for anything that you're doing, and it'll just overwrite whatever you've got there before. Your caption extensions are .txt. Resolution, very, very important, this one. In this case, I've just set it to 256 by 256. This is the biggest influence upon how much VRAM, how much GPU VRAM is going to get chewed up in your training. I've never been able to go beyond 320 by 320 before I hit my limit of 32 gig, because my GPU's got 32 gigs of RAM. If your GPU only has 24, then you're going to be even further limited here. So it's going to be a combination of this and your target frames, which will determine how much VRAM is going to get used. Okay, so 120 frames. We know that one video operates at 16 frames per second. So that's going to, so 120 frames is going to give you 8 seconds. So you remember before, our videos are 8 seconds. That's 120 frames. Oh, and by the way, when you save your videos, try to save them as close as you can to 16 FPS. In case of Premiere Pro, I could only save them at 15, but that's fine because the difference between 15 and 16 means it would be slightly slower, or just very, very slightly faster in learning that the speed of that motion. Okay, so 120 frames, I want to capture all 120 frames of that. You might find you won't need it that much, you might only need 5 seconds, in which case you can reduce it down to say 70 or 80 frames, and that will then help with your memory. Then you might be able to get more resolution that way. Number of repeats is you always have your batch size at 1, because I mean just memory is just never going to be able to do anything beyond 1. If you try to do 2, your memory just explodes. Number of repeats is important because it basically says the number of times it's going to go over that data set of videos, and imagine that they're new and different videos that it's trying to learn new information from. So you trick it into thinking that it's got something even more to learn, because you want a nice big data set, and 16 videos is actually quite small, even though they're very, very action packed. I have used, for some of my other LoRAs, I've used up to 30 videos. But if you look at other descriptions of other people doing successful LoRAs on Civit AI, they often will say they use anything between 15 and 30. So your target number of videos, I would go between 15 and 30. Anything beyond that, it's a tremendous amount of work, and you get diminishing returns. So yeah, you don't need to go above 30. So that number of repeats, again, just ask your AI that you trust to ask it what should I use there. In this case, ChatGPT suggested I use 8 for a data set of 16 videos, and that's what I did. Okay, frame extraction is full. That's basically everything. Get all the frames, and there's max frames as well. I don't quite understand why that seems redundant there, but anyway, frame stride is if you want to actually skip over frames. So let's say you had a 16-second video, which you're capturing a longer sequence. You can squeeze more into RAM by doing frame stride of 2, or skip over every other frame. But the danger of that is you can lose smoothness of fidelity of motion. Okay, so if you have some very fast motion that's going on, you don't want to frame stride it. You want to capture every single frame. Okay, so this is our TOML file. It's our config file. And it's referenced when we're doing our text encoder caching, our latent image caching, and the actual run command itself. So let's talk about the more important switches within the training command. When we're doing one video, we have to specify this very specifically. This is an image to video. So we're going to be doing an image to video model training. You can also do text to video, of course. That's different. That's probably harder. I think it's harder to do text to video because the model has nothing to go on except pure text. Whereas at least with image to video, it has a source image that it can start with. So here you set your task, you say ITV, and A is one video 2.2. If you were doing 2.1, you wouldn't have A, it would just be ITV 14B. And your DIT is your actual model. And here I've got my WAN high noise 14 billion FP16 model. Okay, because this is our high noise, this can be our high noise prompt, our high noise training set, and our low noise training set. So we've got our low noise and high noise here, two separate models. That's your save tensors file that you keep in your in your probably in Comfy UI or your automatic 1111 directory where you keep your diffusion models. It doesn't like the in this case, if you're interested, it does not like the FP8 scaled model. So you have to use the full 16-bit floating point 16-bit. It's about 28 gigabyte file. Yep, here's our config file, dataset config, STDPA, SDPA. That's all the standard mixed precisions, FP16. Leave it at that. Optimizer type. I've always used Atom W8-bit. It always does the job. There are alternative ones out there, but that's more for advanced. If you're basically an elite motion LoRa specialist, you can look at other optimizers. There are these things related to weight decay. Again, this was a guidance from the AI, which basically told me do that. It's supposed to do something cool. Learning rate is important. Depending upon how successful you are on your first run, the AI might suggest that you try a different learning rate. If you have too high a learning rate, so here 1e to the minus 4, that's 0.401. Always start with 1e4 for your high noise for 1, or just if you're doing Wan 2.1, 1e4 is fine. But if it's too high, it can skip, it can miss. It's a whole big subject, but it is very, very important that you get. If your learning rate is too low, I think there's always a danger that if it's too low, it can get stuck in something and it can't move forward, and so your training will basically stall and it will not progress. If it's too high, then I think it can be unstable, and it won't be able to settle down. So if it doesn't settle down and your loss curve, we'll talk about loss curves in a minute. If your loss curve is going all over the place, then it's likely your learning rate's too high. If the loss is not moving, then the learning rate's too low. But it's anything between 1e to the minus 4 and 5e to the minus 5, which is half of that. If you can get your head around exponential math, that's 50% of that. Okay, because we've gone down on the exponent and we're saying 0.5 of that. Okay, anything between those, it's usually that range is fine. So if you ever any doubt on that, you stick to between those two numbers there. The network dim is important because it determines the breadth of the matrix, if you like, that the AI is working with in terms of spatially conceptualizing what it has to look at. I know that was just word salad, what I just said there. But stick with anything between 32 and 64 is usually enough. For SDXL image finessing, for fine image training, for doing character LoRAs, this will often be higher. But for motion, it seems that 32 is usually enough for that. Okay, so your network dim, just leave that at 32 unless you feel the need to dick with it. Discrete flow shift, I have advice from that to vary that depending on thing, but ask the AI about discrete flow shift and it will give you an opinion on it. We talked about this min and max time step. This is just for Wan 2.2, and note that this again is different for your high noise to your low noise. Okay, 900 to 1000 for high noise, 1 to 400 for low noise. Okay, max train epochs, very important. That's going to determine how long your training is going to go on for. For high noise, apparently you don't need a lot. 20 is usually enough, but 40 is potentially or more for your low noise. Okay, so your low noise is going to take longer on Wan 2.2. If you're just doing 2.1, a single training step, I just always set 40, because you can always test this. You can always stop at any time and just see how and test it out and see how it does. Okay, save every n epochs. Always, I just leave that at 1. It means you end up getting bloated disk space. You can always delete them at the end once you've got the one that you want. But if you set that at 5 or 10, you know, you could end up maybe missing a particular a sweet spot that's going to give you the best motion without overfitting or underfitting. And when we talk about overfitting, we're talking about too much training, where the model locks on to some specific detail, which it would then reproducing in inference, which is an unwanted detail, such as, I don't know, maybe it would lock on to the character's face, and you don't want that. Now, you remember on the videos that I had, it was all Jessica, right? Although, to be honest with you, you could, I mean, yeah, you can see her face. So if it overfitted, we'd end up getting Jessica's face trying to be superimposed onto our LoRA during inference. And you see that in some of the comments on LoRAs on Civit AI, where they say it's changing my character's face. Did you use different models? Did you use different people when you on your source videos? So if you end up using the same person on all your videos, then there is a danger that you can overfit to end up trying to change your character's face to that person that you were using. So ideally, you want to have 4 or 5 different people doing the actions that you're recording on your source videos. So and that's one example of overfitting. So if you kept on training forever, like let's say you did, I don't know, 100 epochs, it's probably going to overfit, and it will lock onto something that you don't want it to lock onto. Okay, so again, it's this fine line of training it enough to pick up and learn emotion without overfitting it. Okay, so again, it's just going to come through experience, and to a certain degree by looking at loss curves, which we're going to talk about when we talk about the actual running of the training, and looking at it in Tensorboard. We'll be able to actually, you can often judge if it plateaus out, then that's usually going to be enough. Anyway, we'll talk about that in a minute. Right, so output directory and your output name, fairly self-explanatory. Here, to keep track of, it's important that you have some kind of naming convention. Here you see I've got the actual name, the description of the motion that we're trying to record, pole dancing, I to V, image to video, as opposed to text to video, 2.2, meaning Wan 2.2, high noise, and then V 0.1, the first attempt to get this right. Okay, if I wanted to do this again, redo it, I would go to VO2. If I was doing text to video, obviously that's going to be T to V, and it's supposed to I to V. Okay, logging directory, you're going to be setting that to your Musubi, some directory that that Tensorboard can reference. Okay, I'll talk about Tensorboard in a minute because I mentioned it a couple of times. And if you've watched my character LoRA's video, then you know all about Tensorboard. And then there's a log prefix there just to help with Tensorboard. That's basically it. Okay, I know it's a tremendous amount of information there, but you know it is what it is. You're going to find that as you're setting up your first training run for the very first time you're doing Musubi, you're going to get lots of errors, and as I say, it's going to be lots of hair pulling and feeling that you just want to throw yourself out the window because you just can't get it to work. So you just have to follow the docs through and have the AI help you without the AI trying to guess. Just say, no, don't guess, just tell me what the docs say. Okay, but the docs are very good, and I say there is always help there in the forums if you really get stuck. When you're ready to go, what I tend to do is I copy these and I put them in a batch area, so I can then just run these as a single batch in my command prompt. Okay, so I would copy all of that, and there's that final return that you need at the end to make sure that it's capturing that return statement. So we copy all this, and then we paste that into command prompt, and you have your command prompt set to your base directory in Musubi, and then you paste that in. You get a warning. This is Windows, obviously. You get a warning that you're pasting a multi-line. You say paste anyway, and then it's going to then run the caching of the text encoder. Do that first. So when you cache the text encoder, assuming you got it right, it's reading your config file, resolution 256, number repeats 8. It's picked up the video directory. It's found 16 videos, and then there it is. It's done them. Does it very quickly. Text encoder is done very quickly. Next command. Now it's running it in sequence because I pasted multi-line. It's now caching the latents again. It's picked up found 16 videos, same resolution, and then you see you got your target frames there. For some reason it just rounds it down from 120 down to 117, and if you had 70, it ran it down to 67. Don't know why it does that, but it does. It takes a little bit longer. and there we go. So it's finished caching the latents, and then it's actually doing the run command now. So this is a thing that's going to take hours and hours and hours. Firstly, it's going to load. It's loading the WAN high noise model, this 28 gigabyte behemoth, 14 billion parameters, absolute marvel of human engineering to give us these miracles that we do in AI AI art. So as it loads that in, if you get any errors here, you just have to look at the errors carefully, and then if you might know straight away what the error means, it might be obvious, or just paste the error log into an AI and have the AI try to tell you what's going on. But say you're never going to get this to work first time. There's going to be errors that you're going to have to work through. Anyway, lots and lots of information, and this can confirm. You can read through this if you want to confirm that it's actually following the commands that you're doing, like weight decay there, for instance, Adam W, 8-bit optimizer, and so on and so on, and also sage attention. So we're using sage attention, and you want to use sage attention in your inference if you can. It speeds things up. But anyway, it's able to kind of leverage sage attention to use it. Every time it basically runs through an epoch, it'll just keep updating this, and once it gets to the end of each epoch, it'll unsave it. This gives you the estimate here. It's estimating it's going to take about 9 hours. In fact, it doesn't. It takes about 6 hours, but it's just still settling down first. And then you have your loss rate here. Okay, so the average, when we talked about loss on my character LoRA video, loss is basically the difference between what it got on terms of a result when it tried to run a text prompt. So remember, our text prompt is our caption. Okay, so our captions this was our caption. So it tries to basically create a series of images as a motion based upon that text prompt, and then it will then spit out that by reducing noise and all this kind of stuff into what it thinks that you're wanting to ask, and then it will compare that to your video. And if it's completely off base, then it will record that as a loss. It says, well, the difference is between what I tried to do and what the actual video was so far off that I record a certain number. So I'm going to try something different as I go through iteratively, go through it to reduce that loss by getting better and understanding better. So it's through a process of trial and error that the model basically trains and it never understands anything. No AI understands anything. It's just purely grinding through tensor math in order to basically just basically reduce a loss to get closer and closer to that thing that you've told it that you want it to do, through showing a video of something and by actually providing text on it. So that loss curve, we're going to go over to Tensorboard, right? So here we can see we're currently at epoch 20. We're not epoch, we're at step 21. Yeah, so this is, we know that step matches this approximately here. So we can see our loss curve starting out here. It's beginning to again, the loss is the difference between what it's trying to do versus what you've told it to do, and how good its estimate is. Okay, of reconstructing your video from a text prompt. So there's not much to show here at the beginning because, say, it's very, very early on. And I'm going to stop this run now because I don't want it to interfere with the recording because it's trashing my GPU as I'm doing this. I'm just going to stop this. Here's one I prepared earlier. So this is the high noise one, and here's the low noise. Right, so with high noise, we only went up to 20 epochs and we stopped. And with the low noise, we went to 40 epochs. Now, we can see here that these loss curves are beautiful. Gradual decay. In fact, I could probably have maybe run the high noise a bit longer because it didn't look like it really flattened out. So there's potentially more training to do. And we're going to talk about that when we get to inference because it's not perfect, by the way. You're going to see all sorts of artifacts. Generally speaking, our loss curve wants to kind of fall, but not always the case with WAN. That it will fall, but you'll still get good results. So if you're not getting a reduced loss curve, don't dismiss it. You might still have got some good training, but generally speaking, it's basically this is saying my estimates and my prediction of of predicting the motion is getting better and better every time that gets lower and lower, because the difference between its final is different. The difference between its result and your source images, your source video, becomes less and less and less. Okay, as it learns better and better. Okay, so this is Tensorboard. There's a whole discussion about how to set this up on my character LoRA video. I'm not going to go through it over again, but you need to know that Tensorboard is there and it's your friend and it helps you in understanding what's going on. So I think that is it in terms of training, discussion of training. You're going to be looking at many hours of crunching and GPU trashing in order to actually get this to come through. Okay, in the case of this particular run, the high noise run was 6 hours. It was 6 hours to do the high noise, and it was about 11-12 hours to do the low noise training. So that was 18 hours, and that was on an RTX 5090. So if you've got a 4080 or 4090, it's going to take probably twice as long, maybe a day and a half. On a 3090, it could be 3 days. So you have to be very patient, and you're pretty much locked out of your system. Certainly you can't use your GPU when all this is going on. Now, I still have my old 3090, so I can still use it to do other things with, although I have to be very conscious of the fact to not overheat my system, because as I say, the 5090 is very hungry. It will use, if you look at NVI top here, this is my 5090 GPU will often go up to above 450 watts of power when it's doing video training or even character LoRA training. Produces a lot of heat, and the 3090 is not as heavy, not as hot and heavy, but it's not even half as powerful. It's actually more efficient per watt. Anyway, it's getting into discussions about GPUs. Right, that's it for training. Let's go to talk about all the goodies that you get at the end. Inference. Now, I just happen to have one loaded up here. This is Kayla, and here is our prompt. So our prompt is pretty much the same as the caption that we used. One girl pole dancing, dancer spins and twists her body around a pole. I added some additional ones in there to try to kind of tighten up the some of the issues that I was seeing, and let's talk about those. Anyway, so this is a Wan 2.2 workflow. If you want more information on this, go and watch my Wan 2.2 video. I don't want to go over the same ground on there again. But here's our source image. I created a source image using a pole dancing LoRA for Pony, for Cyberrealistic Pony. I ran it in Cyberrealistic Pony to produce an image which I could then use as a source image to actually initiate. Right, so here we've got our video models here, Wan 2.2 video models, high and low noise, and say we've got our pole dancing LoRA loaded in there. Okay. Now I'm going to run just to demonstrate this in real time, so we can see the difference. Okay, so I'm not faking any of this. So we're going to turn this off. So that we're going to say, hey, Wan video, have you heard about pole dancing? Yeah, I didn't think you had, because we're going to show that if I tell you about pole dancing without actually having a trained LoRA, you're going to have no idea of what that is. Okay, so let's go and run that now. We're going to run it without the LoRA, and let's see what it does. Alright, it's coming to a finish now, so let's just see how much Wan video knows on its own about pole dancing. Here it comes. Yeah, that's actually not bad. That's not bad. It did a better job than when I first messed around with it. But you can see there's some artifacts there. Anyway, actually, I'm quite surprised about that, because when I had another image, I'll show this other image here that I used. She just flapped her hand around and didn't do anything. But there, she's actually doing something pretty useful. All right. So that's actually almost invalidated the argument. I was hoping that she was not going to be able to do anything. Right, now let's actually turn on. I'm going to set the strength to 1. We're going to talk about that. That strength thing is going to be very important. and I'll set the low noise to also to 1 as well, and then so using this exact same prompt, we'll now run it with our new LoRA that we've trained with all that goodness, all that good information from Jessica Marsh's videos, and let's see what Kayla can do now. Okay, here we go. Alright, so it's finishing up now, so let's see what the difference is. So strength of 1 on high and low noise, so high noise again, coarse motion, low noise, fine motion, fine details. Let's see what the result is here. Okay, so obviously a little bit more going on there, but a lot of impossible articulation. Kayla is she can't really do all that things, you know, that she's doing there. But it actually, one thing it has is it's managed to get the collisions between her body and the pole not too bad, but there's a lot of insane contortionism going on there, which is just obviously simply impossible. So one thing I experimented quite a lot with trying to remove these, and so what I was able to settle on was that if I reduced the strength of the high noise, it would basically cool it down a little bit to stop her trying to reduce her doing really nutty crazy stuff. Okay, and with that down to 0.5, this was the result I was able to get. So you can see that she's a little bit more calmed down, and not as much contortion. But what I found was, by the way, when I did this training run, which just took a total of about 18 hours, I actually got my I got one of my parameters wrong. Yeah, when I did this training, I had that setting in my low noise. So I actually really need to redo this. But preparing a video like this takes hours and hours and hours, and I only have the weekends to do it on, so I'm not going to have time to redo this training. Here are some other videos of some of the other girls doing it, doing their stuff, and you see that it was a very ambitious LoRA, this, I think, because I think as I just said, I violated my own principle of don't be too ambitious. And pole dancing, there is a lot going on. There's a lot of different movements. So maybe the correct way to do this would be just to restrict it to a very specific spin around the pole or something like that, without doing all the crazy stuff that Jessica was doing in the videos. I mean, there's just so many different motions there. So this is probably a salutary lesson in not being too ambitious. Okay, but you can see that the general idea was that we were able to record and instill into the AI some of the concepts of putting those motions, some of Jessica's motions, into an AI form, into one of your characters, to get your characters to do stuff, which is just incredibly cool. And you know, we've never been able to do this in the entire history of human civilization. So to be at the cutting edge is very exciting. But it's also it's like bleeding edge. So you're cutting yourself all the time and screaming and going crazy because you know it doesn't work, or it won't do the motion that I'm asking it to do. So on that general subject of when you have inference that is disappointing, that somehow didn't capture the motion, you then have to go through the painful process of trying to troubleshoot and debug why the motion didn't get captured. Okay, now the first thing, and this is where you can try to work with ChatGPT or Grok to try to help you here and try to debug it. But as I say, because it is an order of magnitude more difficult than SDXL image character LoRA training. Okay, much more difficult. So there's only really a handful of people, for instance, I see on Civit AI, that are doing WAN LoRAs, because I think most people will probably just run away because it's just too difficult. Anyway, so debugging it. First things that you can try is to work on your prompt, to try to get a better prompt to get that motion coming through. Perhaps more importantly is getting the strength right. And this applies to character LoRAs as well, SDXL LoRAs, not just one video, not one motion LoRAs. This strength is incredibly important. So if I turn that down to 0.5, I get less anomalies, but I don't get as much motion. If I put that up to 2, it would probably be even more extreme. And to add even further complexity, you've got high and low noise in Wan 2.2. Okay, again, that's coarse, big motion, big body movements, intention to move versus once it is moving with low noise, doing fine details. And fine details does include, as I remember, it does include collisions between objects to ensure that objects don't move through each other and things like that. So setting up those, getting your noise levels right, you just have to experiment with them and find out, if it's too strong, you can create anomalies. But if you've whacked it up to say to 1.3 or even 2, and you're still not getting motion, then it's likely that your training set of videos is too diverse, or more likely that your captions are somehow not right. And honestly, to debug that, it is hard, and it can take sometimes 3 or even 4 iterations to basically finally get a result that works. And I have got things to work. They are NSFW LoRAs, and you can see those on my Civet AI page. I did one recently which relates to fingers, which has been very well received, and some have said, yeah, this is the best one we've had so far on this particular subject with Wan 2.2. And just on a general note, by the way, Wan 2.2 is, I think, so much better than Wan 2.1 in that it just understands motion so much better than 2.1 does. And likely when 2.5 is released to the open source community, 2.5 is available now on the Wan website. I hadn't used it because it's censored, so that would be boring, wouldn't it? When 2.5 comes out, it's probably going to be another leap forward again. So this will get easier. But for now, just be prepared to be in the trenches and fighting a lot of battles to get your characters to do those actions that you want them to do based on the training videos. And one other thing I'll make a comment about is your start image. If your start image is different to the camera positions that you have on your training videos, then that might be too much of a leap as well. So again, as a debugging step, try to get your starting image as close as possible to the angle of the camera and then the position of the body of the original videos. If you get those as close as you can, the starting image, then that will help the image, the model to lock onto that. So your start image is important, and this is another reason why text to video is a different beast entirely. I'm not going to cover it here today. I don't really use text to video, but other people do, and they moan about it if I make a LoRA and I haven't done a text to video version. So I think that is it. I can't think of anything else to discuss here. I think I've covered everything. If you feel I've missed something out, just let me know in the comments. If you do have any questions on this, I'm sure you will have questions. Just shoot them out. I'll try to answer as best I can, but in terms of trying to debug specific things, I'll do my best. But I say every situation is very, very different, and everybody's system hardware is very, very different too. Okay, that's it for now. So thanks again for watching. Thanks for staying to the end, and that your brain hasn't gone to mush already. Check out my LoRAs that I've got on Civet AI. I'll link that in the description. And if you like these videos and want to support my work, then please hop over to my Riot Models page, and you can subscribe there and support me there. And in reward, you get to see the girls in exclusive private lives that you don't see anywhere else. So there's all exclusive content there on my Riot Models page. Okay guys, so thanks again, and I will see you in the next video. Okay, bye for now.